Hi everyone, my name is Jeff Engel. I'm a cloud technical marketing engineer with Checkpoint on the Cloud Rocket team. Today we're going to be talking about a use case for our integration of CloudGuard Network Security for Azure Virtual WAN. And the simple use case and the demo that we'll show you is simply how it is secure and how the security between vNETs can be greatly simplified with the integration. So a quick agenda. We're going to go over a quick Azure Virtual WAN review, show you the reality before Virtual WAN came on the scene, which is kind of one and the same, and then the new normal, which then includes also the demo. So let's get started. So today what you have is, typically have a bunch of vNETs in most cases and additional spokes, but for now we're going to talk about vNETs, and you have to have peering definitions defined in order for them to talk to each other. When you add a whole bunch more, it gets way more complicated, way more complex, and a lot more overhead. And so that's one of the biggest reasons why Virtual WAN was brought to bear by Microsoft, which is it's a big deal. It's awesome. It makes things way easier. And so instead of this crazy combination of interconnected links, Virtual WAN makes that way simpler. And this is a quick, simplified diagram that shows that. So instead of having all those cross-connected peerings, you simply point your vNETs into the hub and it takes care of it. Same thing goes when you add those same additional vNETs. Just makes a much cleaner view. And so the beauty of this is that Checkpoint CloudGuard Network Security lives inside the Virtual WAN hub. And so that all those connected, peers can be secured. All those connections between vNETs can be secured. Now, just to be clear, you could definitely have done that in the past. You just would have needed to architect it correctly. And that's still a valid solution, and that may still be a solution for organizations going forward, depending on their requirements. So you'd have a dedicated vNet for security, and you have your firewalls deployed in there, but you'd have to steer that traffic into that vNet for that security to be applied. So let's get right into the demo. So the first thing we're going to take a look at is my vNet configuration. This is a classic vNet configuration. I've got, go back to vNets, got 3 main ones. This is my management servers, but we're not going to talk about that today as part of this discussion. But I have 3 vNets. This is my prod vNet. I don't have it labeled that way, but that is essentially my prod vNet, dev, and DR. And if I jump into each vNet, you'll see the standard Azure peering definitions, which is fine and dandy. And you saw the image before, but as you can imagine, if you add more and more vNETs and you have to peer them and want them all to talk to each other, this list and this management of these peerings is going to get extremely complex, extremely time consuming, etc. So big reason why Virtual WAN was brought to bear by Azure, and we are gladly taking advantage of this. So just real quick as an aside, in order to secure that traffic properly, you would also have needed to create a vNet to deploy your security into. So, which is fine. That's still completely possible today and still a valid solution. And in certain cases, it's still going to be a good solution for people, for organizations, depending on their needs. But it's just another step that you'd have to do to steer traffic from these different vNETs into the security vNet in order to secure traffic between vNETs if you so chose. So something to keep in mind. All right. So what you would do in the case of Virtual WAN is, here's my vWAN already configured. So what I'll end up doing is replacing the peerings with vWAN connections inside the vWAN definition, inside the vWAN properties right here. So I'm going to go ahead and remove these peerings because we're not going to need them anymore. You can have them both exist, and if they both exist, the standard peerings will take precedent over the vWAN hub peering definitions, or connections as they call them. I'm going to go ahead and delete the peerings from here as well. And so now that that's done, we can go to the VWAN definition and add our connections to VWAN for those same VNets. And so by doing this, it automatically gives us access to whatever security we have deployed, and we'll show this as part of this as well. So any future VNets that we add, give it a name, resource group, prod, create. We'll add each of these and each of these VNets as a connection. And so once those are added as connections, we can automatically configure them to steer their traffic depending on our routing intent. So we'll wait for those to get connected, and we'll take the next step. All right, now that our connections are successfully connected, you'll notice that they've automatically are associating their route tables and propagating their routes, and we don't have to do peerings between the various VNets. It's going to do all the peerings for us. So we'll have to connect it into VWAN, but we don't need to do the extra peerings with each other. So it's going to save a ton of time. So once that's configured, go back to the hub definition or hub that we have set up and configure our routing intent. This is what's going to steer the traffic into the CloudGuard Network Security appliances, and I have that already set up as well. But in here, this is where we have it set up. So we're going to send internet traffic to the checkpoint NVA, as well as private traffic to the checkpoint NVA. And the default private traffic is the RFC 1918 prefixes. You can add additional prefixes if you so choose to consider those as private. So jumping into a virtual machine that's inside of one of the VNets, this kind of give you a flavor of what is possible now. We'll grab a serial console of one of these VMs. We'll get logged into our test machine here. Alright, so we'll do a ping externally. That works. We'll just do a curl -k. To generate some additional traffic. We'll ping laterally to some machines that I know are next to us, another VNet. So 10.60 is the dev environment. 10.70 is the DR. One thing also to note that I'll show you why it matters here in a second is on the VNet definitions themselves. The VNet definitions themselves, I've also configured tags. So for dev, I have environment dev, for DR, environment DR, and for prod, environment production. And so why is that important? Is because now that we have not only your VNets configured inside VWAN to talk to each other and be able to and be secure by going through the CloudGuard Network Security NVA, we also can use that tag definitions to define our security policy. And so it'll get us logged into our checkpoint management station. And what I've done on the checkpoint security management station is connected this management server to the Azure subscription, and which automatically allows me to pull in the tags from those my Azure subscription. So you can see here, controller Azure, Microsoft Azure, and here's the tags that I was able to consume. And in this case, I'm allowing those VNets that are tagged that way to be allowed to talk to each other and as well to get to the internet. And so if I look at the logs for that rule, example, which is these tags, here is the machine I was just on, doing those ping requests to both 1070 and 1060 1.4 on each, as well as that egress traffic we just did. Should see that fairly easily. I'll clear out that NTP traffic, and there's my pings to Google, and I'm guessing that some of this traffic is the traffic to Yahoo. There's my Yahoo traffic. So that's really it in a nutshell, to really kind of illustrate how clean and simple the integration is. It really simplifies not only the Azure configurations, where the vNet peerings and creating that hub and spoke model, but also the integration with Checkpoint. And then on top of that, utilizing the CloudGuard controller was what we call it, to connect into your Azure subscriptions to consume the tags to create policy with. So, just real quick to add on to what I'm saying is, any other vNets that you add, if they have the proper tagging and as part of your automation processes, etc., and your security policy is configured the way you need it to be, you don't need to come in here and make a firewall change to make it come alive or to be secured properly. So that's a pretty powerful combination, and it allows you to really reduce your overhead and amount of time taken to manage your environments. One thing additional to add to what we just showed is they'll kind of go back one step and show you the peering definition for each VNet. You'll see a single peering into the hub, and that's what does the magic to allow us to do all of the peering automatically with all the other relevant hubs or relevant VNets automatically, instead of having to have a individual peering definition for each VNet that you want to peer with. Hope that makes sense and helps.